Hey guys, yeah, welcome to another one of those Sunday weekly streams for Sparky stuff. And yeah, I've got some more stuff to show you. I've got a nice guest for tonight, and very exciting, hopefully. So I don't have really a big plan made up, like what's going on or whatever. So maybe I suppose we just jump right in, shall we? So on the last streams we discussed SDFs a lot, and I think we need to follow up on that. We did a little bit of SDF stuff with Noland, obviously, and we also did. Oh, did we talk about SDFs? Maybe, I don't know. But we need to do it again today, because what we want to do today actually is talk a little bit about different ways on how to do volumes in Spark. Like this light ray stuff Josh has been doing. I did a little filter with that as well, and we might start with that and then venture into volumes. So what I'm talking about is basically this thing here. I can show you real quick. So it's this. Oh, gotta get this cable here out of the way. Quick. Oh no. Yeah, better. So it's this thing here, and it's based obviously on this cool idea by Josh Beckwith, and also some other people have been toying around with similar things. So Marius Eder, who's also on the stream, he's been doing some really cool shit recently, also with volume stuff, and basically everything relies on the same idea. And the idea is that you just basically use planes and stack them up. So, let's maybe jump right into this and talk about that a little bit. Let's see, where do we start? So, okay, so here's our Spark scene. And then the way it works. I should have that prepared here somewhere. Yeah, there you go. So this is basically this filter I was talking about. And yeah, so basically the way it works, you see the guys, doing nice volumetric rays, and we can also switch over to ourselves here. Woo! And those things here basically, right? And I think I'm upside down if I switch to this camera. Let's try that. That doesn't work. Yeah. So those volumetric rays here basically, and the way it works really, it's just a bunch of planes really. In this filter we're looking at right now, I'm also moving them around a little bit to give this nice aura. It's also what it's called, this aura effect. And if you click the buttons, you can change colors, and you can change patterns, behavior patterns. You can try it on Instagram, and you can get the scene file on Gumroad. But basically, the idea is always the same. And let's just build it from scratch, I suppose, to get going. So essentially, you just take a plane, and then you want to scale that to the size of your screen. And I'm just going to do it manually now. You can do it with patches. There are a bunch of things you can find on the forum. Then you just put a material on it. You take the camera image and use it on the material. And then you set the material to add. And then you just want to add a bunch of planes and stack them up like so. Let's say, I don't know, a bunch of them. like so. And then let's switch to my camera again. And as you see here, this doesn't look too great. This is probably because these planes are too far apart. But if I throw it under null and then scale it down a little bit, and then obviously you probably want to adjust the opacity a little bit, but see what's happening here. It kind of looks like this this effect that the areas are coming towards you. It's a little bit hard to see, probably because they are not stacked properly. But of course you don't want to do it in this way, but probably you want to do it in a smarter way, and I would suggest that you do your scene not in Spark directly, but just use a 3D tool to do that, a Cinema for example. And there you can basically just stack up scenes, you know, throw them in, similar effect, but just much easier to make instead of just manually throwing them in, right? So let's see if I maybe have that prepared here. Yeah, I have this plane stack obj, well, FBX. So I'm just gonna take this, throw it in. So those are, oops, oh, it's probably not oriented correctly. Yeah, to turn it around 90 degree. And then it's also a little bit too big, but now you have a stack of planes, right? And if you now put the material on it and it's way too bright, tone that down. See, now you have the kind of glow effect in the camera, and we can actually make it more intense by throwing just a smooth step between the camera texture and this, which basically just takes the brighter values, and we can make it even more intense if we do this. And what you can see here, you have like here, see, you have those kind of God ray type things, and looks actually cool if you put your hand here, see? And you can adjust the intensity of that by just playing with the opacity of your material. Woo! Now it's getting pretty intense, and you can adjust the length of it by basically just scaling the stack of cards out. And so that's it. So this is, you know, God rays. Let's do a little effect. So, all right. So I said we want to talk about SDFs today. Why do we care about SDFs? Well, because what's interesting here is that I did a little test recently, which I thought was pretty interesting. Let me just pull it up. Let's see if I can find it. We do it together. There's so much shit going on. Yeah, it's this. So this is basically the teaser for tonight, right? Where I do the voxels, right? So what's going on here really is that I had this idea of saying, hey, if we use the planes to do volumetric stuff, and then actually Marius was doing some cool shit with it as well. I think I have it open here somewhere. Yeah, here. And this is actually where I started investigating this effect here, this donut, right? Like this is the latest version of the donut. But basically, this stuff here is what I started looking at, like this volumetric stuff. And what he's picking up on actually is something that's done in Houdini. And it's just a bunch of animated texture sequences spread out on planes. And originally it's from the well, hold on, I did comment that, I think, from the Infiltrator demo from Unreal. And there's a nice making of where they break it down, and that's, I'm not going to, you know, watch the whole thing, but just going to talk over it a little bit to give you an idea. So this is essentially what Marius is doing in this effect. And so this infiltrator demo is already a little bit older here, 2014. Oh, it's actually funny. Last time we did talk about Unreal Engine as well, and now we talk about it again. And now, hold on. See this explosion there? This explosion? Oh my god, explosions. Oh shit, my other camera crapped out. So how this is done, actually they explain it here. Hold on. So basically they have a simulation done, in 3ds Max. They don't do it in Houdini, but they do it in 3ds Max. And they have this explosion going on, and then this is a volume, right? And then they split this volume up in planes, right? As you see here, those are the planes. And then they just render out basically one animated texture per plane. And this is what it looks like then as a sprite sheet. And if you play it back together, it looks, well, this is the setup in Unreal, but basically you see here, those are all the different sprite sheets. And if you put it together, then it looks like in the demo, as you see here. And if you look at it from the side, there you see one issue of this technique actually is that you will always see kind of like the sides of the planes. And this is the same problem we have in Spark. So it looks great if I look at it head on like this, but now if I turn my object for volumetric stuff, see now the planes basically become invisible, obviously, right? Because you look at it from the side. So that's the idea. And now let's maybe take 3 steps back and talk about SDFs again. All right, so we will see in a bit why we care and why that is relevant. But let me maybe just go through the chat really quick and see if there are any questions I might want to address. Yeah, people are talking about who did that trick first, and I just want to, for the voxel stuff, not necessarily the layer, like the glow stuff we're looking at now, but the voxel stuff I was just talking about. This is actually because, this is kind of like an older effect. I tried that like way back in 2018 or something. Unfortunately, I can't find it right now. Let's see if I can find it really quick. But I mean, doesn't matter who invented this. It's always someone who did it or something similar before. The question is where do we take it, and how can it be fun, and how can we learn from it? And yeah, scripting. I'm not gonna fuck with scripting for planes. All right, shortcuts. That might actually be an interesting one. I've seen on the forums also recently that I haven't even looked into shortcuts, but like this is something you could do probably if you want to speed up your workflow. Nolan was saying there are shortcuts to do things. I mean, obviously I've done it with a shortcut, but like there are more shortcuts that might be an interesting discussion to get into that. Inigo, yeah, the SDF guy. Yeah, we're going to talk about that in a second. The measurement, that's also a good one. Okay, so apparently what I figured out, or what I found out, is that the world scale of Spark is in meters. So actually, if you use an FBX and you have the proper scale, then the numbers you put into Spark, they match with the SDF, which is gonna become relevant later on. Okay, cool. So now let's look at SDF. So what's an SDF, you ask? Well, glad you ask. Let's ask Wikipedia what an SDF is. So SDF is Syrian Democratic Forces. No, of course not. But it's a science distance function. That's what it is. And so if you read this description, you're going to be like, what the fuck? Oh no, wrong one again. Yeah, because it's crazy. No one understands anything. At least I don't. So let's not do that, but go into Spark directly and talk about it there. So basically, as you might know, you can, I'm just gonna start again with a fresh plane to talk about SDS. And say, hey, let's do a new material and do a flat material. And then you can use the built-in SDS. And if you type in SDS, you have a bunch of them. And let's start with circles. So you have the parameter, you know, where the center is, how big the center is. And if you put it in, you see nothing. So if you swivel it and say, hey, we want X, so the value of the color basically, and we want an alpha, you see that this starts becoming something. So you see those little edges here. So if we take a step, actually before the swivel, we see a circle. Well, that's great. So as you can see, it is a gradient before, and the step basically is like a hard cut, if you will, right? Like anything below 0 is black, anything above 0 is 1, so white. And that's also an indication that there's an above and below 0. So a signed distance field is really just a mathematical representation of like basically like a distance to something. That's why it's called distance field. And signed distance field is just because the numbers can be signed, meaning they can be positive or negative, so they can reach below 0. So that's why it's called signed distance field. And essentially, you know what this guy is doing, the circle here, and we see it if we connect it directly here again. It's a little dark, so we can just add something to it. Then we see it's gonna get a little brighter, maybe a bit easier to see. So this is basically what it is. And it's saying, okay, this color here for each of the pixels represents the distance from that particular pixel to what? Well, the center of my circle. So, you know, this is the center of my circle. And that's the distance. So if I put the center on 0.5, which is the middle of the square in UV coordinates, then the distance from this pixel to my center is 0. There's no distance. And the distance from this pixel here should be 0.5, right? Now we brightened it up a bit. And these things are also relevant because when we talk about vertex displacement, and this is something we're going to get into later when YEGOR is joining, unfortunately, you cannot use those SDFs to displace vertices. So if I wanted to take this basically as a, you know, a height map or like a displacement map, I couldn't do that. So let's look maybe into how would we build our own SDF. Okay, so what we want is the function that gives us the distance between a point here and each of those pixels. So in order to basically, you know, look at each of the pixels, this is what a pixel texture sampler is doing essentially. If you take the texture sampler and you give it the texture coordinates as UVs, it will basically go over each of the pixels in our plane and look at, well, whatever we input here. So if we input a color here, and let's make it red, right? Then we will see that the plane becomes red. So why? Because at each point on our square, at each pixel, it's looking at this. So what about we put something else in to get the circle? So we said, well, a distance field is the distance. So let's just say distance. There's the function, distance. That's great. So we have two coordinates because we have x and y on our plane, right? It's a texture. So it has a width and a depth. So let's make two coordinates. And then, okay, we put it here and, well, nothing happens. Because what distance do we want to measure? We want to measure the distance between our texture coordinate and a point. Oh, look, something happened. So what are we doing? So it's taking the texture coordinate, which is the position of our point on the plane, and it's looking at the distance between this point here and each of the individual pixels. So a couple of things. First of all, why is that just a line, when in actuality, if we put SDF circle here in there, let's try that again, and we put the center to 0, 0, we see that it's actually a nice round space, right? Well, that reason is that if you don't tell the texture sampler to look at each pixel, it will only look at each vertex. So vertex is basically the edge of the object. So it will just look at this point and this point, this point, this point, and color this and interpolate between the values. Interpolating meaning just averaging between the values. So what you have to do is you have to put fragment stage in between, which tells it to go and look at each individual pixel. And this is what it's doing, so it's actually working, right? So that's great. But what we notice is here again, like it's a little, I don't know if you can see it in the stream, but it's a little transparent here. So we have to, again, swizzle it because it's now affecting all the channels. So we want to alpha to always be 1. So this is basically it. So there you go. And now we are measuring the distance between 0, 0 and each pixel. So if we put 0.5 and 0.5, that's it. We have the exact same result as if we would just put this guy in here. Well, of course, we have to put the same value in here. So, hallelujah, we built our own signed distance function. Pretty cool. So we have a circle. And then if we take the step guy in between and put it at 0, it means, again, that basically it cuts off between 0 and 1, and because apparently our function has a different threshold, we need to put 0.5. So at this basically line, this is where our value is at 0.5. Anything below 0.5 will get black, anything above 0.5 will get white. And we can actually, just for the sake of it, probably do the same thing and do an if else or a mix. Probably we can probably do a mix. If we put a mix, oh no, I don't know. Like this, I haven't tried that. Let's not fuck it up. We were having a good roll here, so let's not fuck it up with irrelevant shit. So this is our science distance function, and the cool thing about it is now that we can do the whole other shit that we can do with SDFs as well, on top of which we can also use it to displace vertices, and this is something, again, we will get into later. But how does it relate to our voxel shit, right? Well, if you look at this, you're looking at 2 coordinates, the width and the height of the texture, which is called U and V. And this, the reason it's called U and V is really that it's just 2 other letters because XYZ were already used up, right? So like you have the XYZ space or axes, and then U and V are the next letters in the alphabet. So this is the reason why it's called U and V. So basically the U axis is the x-axis of the texture, and the v-axis is the v-axis of the texture associated with the plane. Right. Okay, cool. So now here comes a cool bit, right? So how about we put 2 and 2 together now, and we take our little plane sky again, or we can use a trick to make it in Spark or whatever, but we're not going to bother with that. But we are just going to go ahead and take our planes we just used to do the nice lighting effect, right? Let's see. Do I have it? Oh, it's still in there. There you go. So this is our plane stack, right? And now let's just give the other material to it. So now, of course, we have stacked planes with a circle on it, right? Okay, so let's maybe do this and put everything on white and just put the circle as alpha. So this is what we have now. Now there's a hole in the planes. Okay, now let's see, what do we do next? Let's first of all subtract it from 1 so that we get not a hole but a, yeah. So this is kind of like, you could imagine it like a cylinder. So it's basically just a bunch of planes stacked on top of each other, and it's kind of like a voxel cylinder, if you will. And if you just take the material and lower the opacity here, see, it looks like a cloud. I mean, this is kind of cool. You could make a light effect with it or whatever, so this is already pretty cool. But going back to the sign distance stuff, this is actually not only working in 2D, but it's also working in 3D. So now what we input as a relevant coordinate we want to look at, like the distance from, is texture coordinates. But what if we put in the local position? And the local position basically tells us the position in the world of each of the pixels, right? So let's try that. Let's see what happens. If we just take local position here, it doesn't work because we are having a distance with only 2 values. So I have to put that on vector 3. And it still doesn't work because the values, even though they are x, y, z, they are actually written with 4 digits. So I could either put vector 4 here, or what I could do is I'm just gonna swivel it around and put x, y, z, because I don't really care about the w. And now we see, oh, I don't know, something is happening. Not what we want. Let's put it to 0 again. And see, there we have a kind of, I don't know what it is, something. And now it is again, it is so blobby because this is only going over the vertices and not over each pixel. So if we put back fragment stage, okay, so this is not, so we have to probably plug it in position also. Let's just an experiment. Yeah, so now we have our nice circle back. Well, that's something. But actually, it should be a ball. So let's just look into why that is not the case. Huh. Well, I don't know, but we can just open my volume scene and then just jump 3 steps ahead because it should be in there, and then we can look at it. Okay, so this is the same idea really, and let's just look into how I did that. This is a little bit more complicated. No, it's in a local space. That's not the issue. But here we have the same thing. Okay, local position, x, y, z, distance, smooth step. Yeah, should work. Smooth step. Okay, let's see. I'm curious now why that doesn't work. Let's see. So because this works, right? Yeah, so this is how it should look like. It's certainly a ball. And here it's not. Oh, I think actually I'm not even passing it to a texture assembler, am I? Oh, interesting. So if I just put it like this. And here another cool trick actually we talked about with Matt Greenhike again is this. If you now what would be cool is to kind of debug this scene. Would be cool to kind of just move our position, move it around and see what happens. And I did this little script to do that, but now the new cool way to do it is to just take a plane, for instance, and then put it in here and then take the bounding box. And that will give you the wall position basically of that plane. And if I just put it to distance, I can just take this plane, move it around. And oh, I think it's probably the orientation of the planes or something. Something weird is happening with those planes. That is certainly the problem. So it might have been something I did in IC, because if it's doing weird shit if I move it up and down. So that might be the that might just be the object I use for this light ray shit. You know what? Fuck it. Let's do it together and do it from scratch. So this is us now in the 3D program. So we're gonna do a plane, and it's gonna be 1 meter by 1 meter. So that's again like this is important, and I want. Yeah, I want 1 segment for starters, and then I'm taking a cloner, and then I want how many copies? Let's say 25, and they should be 2.5 centimeters apart. Let's say so. This is actually no. I wanted 1 meter by 25. Yeah, this is it, and then just bake it down. Select children, connect and delete. And then this would be our FBX we're gonna try it with again. I mean, I know it works because I have it working, but just so that you guys know how it works too. So 25 planes, let's see. Okay, now let's import those guys here. 25 planes. So those are our planes, and then if we throw the same material on there, that should be it actually. Oh, hold on, this is the wrong scene. This is the right scene we want to try. Yeah, there you go. So here we throw our material on. Oh yeah, and it does work, see? Now if I move the plane here, see, we have this kind of hollowish ball type, whatever you want to call it. And now, okay, so now we're just gonna switch the material back to replace. So now it's all white. And now we want to have part of it be transparent. So because it's now not taking the alpha into account, we see everything on all of those planes. But what we can do is switch on alpha test. Yeah, see, and now it's already working. So what the difference between alpha test and alpha is that alpha test is just checking, is there a pixel like at all or not? If there's no pixel, it won't draw anything. If there's a pixel, it will draw it, but it will not blend it. So basically you have this threshold here. And as you can see, we have now a kind of like a hole in our planes, right? So let's just swap it around by, subtracting 1 from our value as the value from 1. And now it's a, well, you could call it, I suppose, a ball, right? In our planes. See, this is basically it. And now we don't see anything, but the cool thing here is that we can actually also put this material to not flat, but standard type, and even use lights on it. So let's see if we put that to standard, and then we have to reconnect it. But first, let's see, make sure that we see something. Put on specular. It's a little heavy, maybe. Then just instead of the default light, put just the point light. So yeah, that we have a bit of shading going on. Extend the range, and now if we put it back to our guy, hold on, why doesn't that work? Oh, because it's a light. If we take the material and put it back to our guy, no, we have kind of like a voxel ball. Very cool, and that's the whole trick. Woo! And again, the problem is that if you look at it from the side, you see that, you can basically look through it. But it's pretty cool because now what we can do actually is we can just do crazy shit like booleans by just subtracting things. So if we just basically take this again and take a new plane, right? And then we're just gonna put that in here. So this is going to be the center of another object, basically, bounding box. Do distance again, and we do the distance from this guy. And we feed it in here. Then we have basically another plane, let's say. So we have one plane coming out of this distance node, another plane out of this distance node. Delete that, we don't even need a texture assembler. And now we can basically just subtract the one from the other. And it's not working. Ha! Okay. Oh, multiplied, of course. Sorry. And now we kind of like have the meta ball type thing. So basically the same as you have with SDF, just in 3D, I suppose. Pretty cool. And yeah, Hongwei, you could actually add a second and rotate it by 90 degrees. But the problem here, I mean, there's a few problems, but it gets really slow really quickly. So because you know, you have to consider that what the computer or your phone has to do is for each pixel on each of the planes, right? You have to do this distance calculation. And the distance calculation is, well, how does it work? The distance between 2 points is, of course, again, and we had that on another stream, I fucked it up explaining that, but it's basically Pythagoras. So if you want the distance between this and this point, it's a squared plus b squared equals c squared. So you want this distance, c squared. So it's like the square root of a squared plus b squared. And square root is like shit ton expensive, so it's really slow, basically. So this is a problem, and you have to do this calculation per pixel, per all of that shit going on here. So it becomes really slow pretty quickly. And now you can obviously do a bunch of optimizations to this. We can talk about. Let me see, what is this chat saying? Noland, I don't think composition or texture assembler makes a difference. This is actually not using the texture assembler at all, right? This is going, but it is using fragment stage, and this fragment stage tells the shader that it should loop over all the pixels instead of all the vertices. If I take this out, right, what's happening is that this ugly shit is happening. So because, you know, each of the planes only have 4 vertices, the values are only being calculated 4 times per square. So this is actually also something we can make use of. So if I, you know, look at hidden lines, I'm seeing each square here only has basically 1 polygon. But if we say, hey, let's maybe use whatever, 32 by 32 polygons here, right? And then we can actually use the fragment shader, the vertex shader, which is obviously much quicker because it doesn't loop over it for each pixel, but only for each point. But it also has lower resolution. But we can actually do that, and I did try that. And I just prepared basically an object where I have 64 planes with 64 by 64 squares, and it actually takes a while to import because it's quite a few points in there. Well, I mean, you know, we can calculate exactly how many points there are. So you have 64 squares by 64 squares by 4 points by 64 layers. So it's, well, you know, 1 million points roughly. So if you take this here, I put it in, you see this looks exactly the same, right? The only difference here is that instead of just being one plane, you have several planes. And if I now use I always have the problem if I export FBX that it comes out with like a whole bunch of texture slots. I don't really know why, so it's pretty annoying because it's annoying to change the material. So what I usually do is I just take this material and put it in here again, which is also interesting because if you look at this, if I plug this material, basically our shader, if I plug it in the same material, right, then it's two different objects. And that doesn't work, obviously, because this local position value here only makes sense for each object. So I don't really know at what point this patch graph decides to which object this information is coming from, but basically what you would have to do is disconnect the other object and then it should work. Let's see if it does work. Oh yeah, of course we have to again put the alpha test back in. Yeah. And there you see that, hold on, let me just switch that off. So, and there you see, this is now the object with small planes, and this is the doing it without the fragment stage, right? Like if I plug the fragment stage back in, it looks the same, right? And the reason being is that it has enough vertices so that it actually can display the resolution, which is quite low, of our voxels, right? So that's cool because this is like already like a huge optimization. I mean, you know, this is pretty detailed now, but we can actually talk about something else, because actually we don't really care about the exact distance of our position to our voxel, but we just care about any distance, you know, we can kind of like art direct it. So it doesn't need to be exact. So we could actually do several ways of getting this distance. And I prepared something for that as well. Let me just pull it up real quick. Oh, wrong. Yeah. No, I'm not tan. I have a new light, and I actually have a bit of color correction. Hold on. It's better, right? Very good. All right. All right, guys. Let's focus here. What's going on? Oh no, you have to get used to the buttons. All right, so this is now again our but you know, like, I mean, this is really kind of difficult to figure out if that even makes sense, because it's quite tricky to test it, right? So, you know, like, this stuff actually works quite well. Like all the voxel stuff works quite well on my phone, which is an iPhone X, so it's not like the latest, but it's certainly not a slow phone. Okay, so anyway, so this is again a scene where we have the SDF stuff running, and this is using several ways to get this effect. All right, so essentially, you know, we have here a plane, right? We have the same we did before. We have the distance from each pixel to the thing. So how do we calculate the distance? Well, obviously we have distance. This is what we just used. So if we put distance here, well, we have to put it through this swivel guy, like so. Hold on. Like so. So this is distance, but we learned that distance using square roots is quite expensive, which if you use it for a texture, it does not matter at all. But if you use it like for 64 planes with everything in there, and then you use it not once, but maybe you have 2 or 3 voxel balls in there, so you use it a lot, so it might get expensive really quickly. So what we can also use is length of the vector. So basically, if you imagine that you want the distance between each pixel and a certain point, you can also just do vector math and subtract one from the other and then get the length of this vector, which is the distance. So that's what I did here. I just subtracted the point from, and you can move around here, right? So I'm just subtracting, basically this is a point in UV space from the texture coordinate, take the length, and that will look exactly the same if I plug it in the right thing. And that looks exactly the same, right? So that's pretty cool already. But there is kind of no way to figure out which one is faster. And what you can also do is you can, if you say we don't really care about the exact value, but we care about the squared value, you can also say, hey, going back to Pythagoras, and saying, well, if I don't care about the exact length of it, but I just care about a relative, basically, you know, I just care about, well, I can art direct it with a step at what point it cuts off. You can also say, well, c squared is a squared plus b squared, so that also gives you a length. So you can just do that, you know, you can just say, hey, again, take the vector here, which is subtracting the position from, like the position of where I want to go, so my mouse in this case, from each pixel. And then A and B would be basically the X and the Y coordinate. So take this, right, the X coordinate and the Y coordinate, square it, so multiply it by itself or put power 2, same thing, add it together, so this is this formula here, right? And then if you plug it in, hopefully at the right position, you get a similar effect, right? It's not exactly the same because it's not the length, it's not the distance, but it's a squared distance. So if I take the distance here again, and then I square it, I do power 2, that should be exactly the same as using this calculation, and it is. But again, you don't know which is quicker. But there's another thing you can actually do, and that is the dot product. So we did look into the, and I'm not going to like talk about it forever now, but we did look into the dot product, and what the dot product gives you is the angle between two vectors. But if you use the dot product of yourself as a vector, it gives you the distance. So if you use, again, like the vector between, you know, what I keep telling about, between the point we're looking at and your position, and use the dot product from itself and plug that in, it will also give you the same result. So it's a squared distance actually, which is fucking amazing. Yes, because what we know is that dot product is actually hardware accelerated in most GPUs. So that means if we go back to our example here, and let's just again, because that should theoretically also work in 3D. So if we take just one sphere here, right? That's our sphere. And then what we have to do is we take the local attribute, subtract the position of our center, which gives us per point the vector between the two. Well, it's complaining because, again, I'm missing this swizzle here. And now if we take this dot product of ourselves and feed that in, hallelujah, it does the same thing. It's squared, so the ball is a little bit bigger, but like it is certainly quicker. Well, I mean, you can't tell it here because it's a fast computer, but on mobile it will be certainly quicker than that. So that's fucking amazing. So those are the two things, actually, off the top of my head, you can do to optimize that stuff. And I did also find a solution for the problem that if you look at it from the side, like so, right, that it disappears. And I am going to show you real quick. And this is kind of like something I did today, kind of like last minute. But this is actually pretty fucking cool, I think. So this is essentially, okay, so right now we are actually not using any vertex shader whatsoever, right? We are using only the color. So we basically, like this shading here comes from the Spark internal shading from my light. I can move it around, you know, just completely normal. I can also use a texture on it if I want. I can just put the camera texture on it and multiply it by my guy. So this is totally working. And well, the camera texture is now this weird. Yeah, so there you go. So I have a, well, cut out, well, whatever you want to call it. But so it's really only adjusting the alpha, right? Woo, woo. That's pretty cool. Yeah. Woo, woo. Yeah, whatever. I don't know. I mean, oh, this is something. I keep hearing the question on the forum. People ask me, well, I don't understand. What is it? What I'm looking at? How can I use it? And to be honest, I don't care at all, right? Like, I don't really care at all whether this makes any sense. You're probably not gonna get like a shit ton of Instagram followers. So if this is the reason you're here, you can just probably go to another stream. What I'm interested in is that I want to learn shit. I'm excited about new things. I'm excited about making Spark do stuff that it's not supposed to. And this is most certainly not what this is supposed to. So I'm really excited about it. So I don't give a shit. Like, you know, don't ask me whether that makes sense. Like, I don't care. Like, who cares? So if you want to do the easy stuff, you know, if you want to know about new features in Spark, which is certainly great, then, I don't know, go to 3 million other tutorials. But if you want to learn the hardcore shit to make it do shit it's not supposed to do, then stick around anyway. Yeah, so sorry for that rant over. Now back to our voxel guy. Okay, so now we are only using the alpha basically to blend in our voxels. But actual proper voxels, let's say, and actually I have to show you something. The Comanche game. I don't know if anyone of you remembers that. Anyone remembers Comanche? Like from the, I don't know when is that from? Well, it's old. Anyway, fucking old. 92. So this is one of the first voxel games. Oh, this does not look like the old one. No, that's certainly not the one. Let's say 1992. Yeah. Oh, there it is. So this is actually, that was super iconic back then because it used, instead of, I mean, this was even before most games could do 3D at all, right? So this is basically more or less where Spark is right now. So they use voxels, and so as you can see here, this whole landscape is kind of like Pyxis, but it's in 3D. And you see that they are always oriented towards camera, right? So you can never look between the planes. It doesn't matter because they render always like a little square, and it's always looking at camera, like a billboard. So what if we could do something similar in Spark? And then I thought, well, maybe we can with Vertex shaders. And I prepared something that kind of works. So this here is, let me just put a nicer background. This here is actually totally it. So this is voxels, but no matter how I rotate it, and I can actually show you, I have like a rotator connected here, but, and oh yeah, it's a donut. I'm gonna talk about this donut in a second also. But I can just now take basically my voxel guy here and rotate it however I want. And the voxels are always facing the camera. Fuck yeah, shark time. So I'm not gonna go into how I did that. this is a little secret. I think you have to find out for yourself. I'm curious whether I did it in a proper way, and you know, maybe you guys even find a better way to do that. But yeah, I think it's pretty good. And if you're a subscriber, actually, you will get the scene file on the Dropbox, and you can have a look into it. and this runs fine on my totally fine on my phone, right? So this is basically the post I showed initially. All right, now last but not least, let's talk about how did I do this donut here? Because you know, how is that a donut? Because we were just looking at distances, and so basically this here. This is our donut. This is basically like the SDF 3D formula for our donut. And it's not yet optimized. So I'm using here length instead of like the dot product trick because it was easier. Unsubscribe. I did not come up with that chip myself, but there's like a whole scene around this SDF, and it's called ray marching. And we did talk about that already. Quite a few times on this stream, but if you look at this guy here, we talked about again like his work already, and he's one of the guys doing crazy ray marching shit on Shader Toy, and he has basically all the formulas for all the stuff here on his website, and this is totally this is totally what we're doing. So this is a sphere, and he's also shading it. So we're not doing that yet, right? You could also do that to actually light it and so on and so forth, but it gets a little crazy then in Spark, I think. But basically, this is exactly what we're doing. So a sphere, right? How do we do it? Well, we take the length of the position of the sphere minus whatever s is in that case. You would have to read up on that. I don't really know off the top of my head, but this gives you a sphere. It's just the distance from the point to each of the vertices. And a box, if you want a box, and a round box, and a torus. So this is exactly what our torus is. So I just took this formula here and converted it into patches. Oh, sorry, wrong window. And there you go, boom, bam, torus. And the cool thing, obviously, now is that this is totally procedural. So I can, as you see here with the animation thing, I can adjust it and make it do crazy things, and no matter how I rotate it, the voxels always stay in position. And the colors are actually just the coordinates mapped to color. So yeah, boom, boom. That was a quick walkthrough through voxels, and again, like I think it's a super exciting stuff. It's super crazy. I've been actually for this think about how to do that for a while, and I'm pretty happy that this seems to be an interesting direction. And actually, Maris and I have talked about cool uses for that as well. We might, follow up with cool shit. Now on the chat there, let's see some questions. Subscribers should. I should probably open Discord and see. I haven't even opened it. But basically, how it works again, like if you subscribed to the channel, what you have to do is you have to go into your Discord. I'm gonna show it again. I prepared it for the last time when I did the stream, but I'm gonna show it again. So what you have to do, you have to go into your Discord. You have to go into your settings, which is here. Sorry, 1 second. So here, this button here, right, next to your name, where it says user settings. You have to go there, and then you have to, under connections, make sure that you join my channel. And then you will get this subscriber only Discord where you can find the links to all the files, right? Now that should work. Yes, great, cool. So yeah, so that was that. Actually, it's kind of funny because I kind of just stumbled upon this whole stuff super recently. I actually didn't even want to talk about it, but I wanted to just talk about this Aura filter and, you know, maybe do a little bit of audio shit and so on. But then I also thought, hey, you know, like there are 3 million tutorials for that already out there, so let's do the crazy shit. Speaking of which, I think now would be a great time to get our guest in, and we will see if that works out. So Yegor, click on the Hangout and then. Oh yeah, also guys, if you have questions, I think now would be a good time to ask them. Oh, there is already. Hey, there you are already. Really cool.
What a second. All right, cool.
Cool. Yeah, there you are. Very nice. So hey, how's it going? Yegor?
Pretty good, pretty good.
Good
Thanks for
seeing
having me.
you.
How are you?
Yeah, absolutely. Well, I'm fine, you know. Same old, I suppose. Yeah. So let me just, I thought I just want to tweak the window real quick so that it looks a bit more professional.
Oh, very professional.
Yeah, that's good.
Nice.
Yeah, how's it going? So you, yeah, hey, we met also in London at the hackathon. So I already know you. We worked together in the same team.
Yeah,
in the hackathon.
Great team.
Yeah, yeah, that was together with Joe also. I don't know if he's here, but for those of you, for those of the people in the chat that don't know you yet, why don't you introduce yourself a little bit?
Yeah, absolutely. So my name is YEGOR, and last time I was employed in a company, my official title was creative technologist. So that's something that I tend to go with. These days, I actually mostly do Spark, but sometimes it's a bit of web projects and all that stuff. And I think I've been playing with Spark for about a year now. And it's actually like really weird because I found so many people who kind of come from very similar backgrounds, because like my background originally is in graphic design, and like literally half of the community is like people coming from those areas and then kind of learning a bit how to code, and then it's like boom, you're a creative technologist. And I mean that means so many things, but I guess AR is one part of it.
So that means you are not in that company anymore. Is that what you're saying?
Yeah, I'm not in that company. I've actually, like, the whole Corona thing kind of messed my plans of changing jobs. So I just quit that company, and I was like, yeah, I have so many interviews, like things are lined up so nicely, and then it's just Corona, and I'm like, all right, I'll just do freelancing.
Okay.
Which is actually pretty cool.
Yeah, yeah. Yeah, I mean, it's great for working from home, I suppose, right?
Oh yeah, like it's a perfect setup.
So are you actually doing also Spark freelancing?
Yeah, actually, like recently. So I think I've been properly doing like full-time freelancing for about a month since I quit.
Yeah,
and now actually like most of the stuff is Spark. Surprisingly, I didn't expect it to be like that many demand for Spark, but maybe it makes sense. Like people cannot go out, and like they would like to bring some experiences in people's houses. But obviously, like it's a really weird situation right now.
And how do people find you? Through your Instagram, or how do you?
Yeah, it's some are through Instagram, some just seen some of my posts in the Facebook group, and that also like brings some clients in. Some are just like from previous connection through work and stuff. But it's like it's literally just the beginning, and I'm still like not sure what I'm doing exactly. Like maybe it will just turn out to be like just web projects and stuff.
And is that the first time you do freelancing, or did you do that?
Oh, before? No. I've started as a freelancer. So basically, my freelancing always starts like with a crisis. So the first time I started that was in Russia, when Russia annexed Crimea in Ukraine, and that kind of messed up the whole economic situation down there. And I realized that, all right, I'm working a job that like makes me like 300 euros per month. And I was like, nah, I'm just not doing that. I'll just go and like draw logos for people in Europe, and they'll just pay me good money.
Yeah,
And I'll be like super rich in Russian standards.
It's interesting. I remember the first time I was freelancing was like back in the Flash days, and I remember there was a forum. I forgot the name, but it was like a chat forum basically, and there was this, I don't know really where he was from, like Eastern European guy, and he was like by far the most talented guy I've ever encountered in all the Flash world, and he knew like everything and was super quick, and and we talked about that, and he said he's living in, I forgot, somewhere East Europe, and he made like ridiculously little money, and he could have become like super rich doing Flash, I suppose. Talking about that, I asked you told me that crazy story when we met, and I asked you whether I could ask you on the chat, so I'm going to do that and ask you whether you
just do it.
You want to tell the people where you're from, because I was like amazed by that story.
Yeah, so like a little bit of a background to where I'm from. So right now I'm based in London, but originally I'm from Russia, and whenever people ask me like where you're from, I'll either do like Russia in general, or I'll do like, well, I've lived in St. Petersburg because that's where I've lived for quite some time. But originally I'm from quite a peculiar place in Russia. And basically it's something that is called a closed town. So they have this kind of thing in Russia. And closed means that it's kind of literally closed. So there's like a wall with like barbed wire, and there are soldiers guarding it. And like if you're a foreigner, you cannot go in there. If you're like not a resident of that town, you cannot go in there. And the reason it is closed is that originally it was like a top secret military city built in 50s, I think, by like the decree of Joseph Stalin. And the whole purpose of it was to have a place like in the middle of nowhere where they can put like a lot of scientists, just like force them to move in there with like their families and stuff. And basically work on this like whole new like nuclear program for Soviet Union. And basically that was the place where they created the fuel for the first atomic bomb. And so it was closed up until like 90s when the Soviet Union collapsed. And I think the most kind of the thing that kind of makes it famous is that in 1950s, when the whole nuclear thing was kind of just starting out and people didn't really know how to deal with that properly, like they obviously made some mistakes, and at some point they kind of made a big mistake. So I think it was like a tank with a nuclear waste which just exploded, and it pretty much just contaminated everything kind of around the town, and it actually like contaminated a huge part of Urals in Russia. And up until that point, it was like, I think it was the most major nuclear disaster in human history. Then Chernobyl came, and that put us on the second spot, and then Fukushima came, and we're still on top 3, which is pretty cool, I think.
It's a little bit like if you're like, it reminds me if you're German. I mean, me growing up as a German in the 80s, like all the bad guys were in movies and anything were always Germans. And if you would like go to anywhere in Europe, people would look at you weird because of the Second World War. And now America took over, and they are the bad guys with the Iraq War. So this is kind of a little bit similar, maybe. I did post in the chat. There's also this documentary about this town, which I watched right after you told me that you're from there, because it was so
exactly. There's a Netflix documentary. It's kind of weird, like obviously they don't really like able to get it like right, just some documentary, but it's pretty like it's worth watching if you just like have some evening to kill.
It was I mean, obviously they want to tell a story, so it's probably a little bit more
it's pretty entertaining.
It is entertaining. Crazy. And
I think like it does shape you in some way, just like growing up in that kind of environment. Because like for me as a kid, there was actually like a limit to my world. So like as a kid, you cannot go outside because like your parents have a pass, and so like you go on a bike, and then like your world ends, and it's
crazy.
Like
it's like Truman Show.
Yeah, exactly.
Yeah. All right, but we're here because of Spark,
Because of Spark, absolutely.
You've been like crazy busy recently. You were one of the guys I've seen, do really cool things on the forum and everything. And I mean, because we work together, I know you do good stuff. So let's see. Did you have anything you wanted to share? We did talk in advance a little bit, and you did a lot of distance field stuff recently as well, right?
Yeah, absolutely. Actually, you just made my job so much harder or easier. I don't know, because like I was literally preparing like half of the stuff that you've covered was like in my repertoire. So I was like, all right,
well, you know what? Probably it's like for me, like it took me forever to understand that shit, and also maybe I'm not the best to explain that. So I would say don't worry about it. Just maybe shorten it a little bit and do it again, because I think it's still totally valuable. And then people already hear it for the second time, and they can maybe jump in and ask questions, or maybe there are new people on the stream, and so don't worry about it.
But see, that's the thing. I think with all these like tricks in Spark that like some people may kind of seem to have like invented or discovered, it's usually like just rediscovering all the like stuff that is already out there.
Yeah.
So I think there is like so many things just like around the computer graphics community which can be like tapped into and just translated into the world of Spark. Yeah. So this is actually just, I guess it's just like us, like not like understanding it even like to be like half of it, is going and like looking at the ideas that are out there. So yeah, let's just start and do something. So let me just quickly share my screen. Share screen. And it goes infinity. Can you see it?
Yeah.
And let's just jump right into Spark. So the thing I wanted to talk about are SDFs. How cool is that? So basically, let's just go in there and let's just add a plane. And I'll just start by simply creating pretty much the same setup that you had for SDFs. And just like show various way you can create that very basic SDF for like a circle and stuff. So as we just seen, it actually can be done in so many different ways. But and here I have some Russian. Here, let's switch keyboard layout. So basically, as Mate just told us, is science distance fields are basically, in a nutshell, it's just a distance from point, and then you can use a step function to pretty much cut off a point at which it will differentiate between 0 and 1, pretty much. And it can also go to negative values. But basically, let's just come here and do some keyboard layout here. And obviously, as we mentioned, that it's always worth putting the vector coordinates in a fragment stage, because here we have the plane, which is just like 1 by 1, and we need to calculate it per pixel. And yeah, we have the sphere. And one thing that I've actually noticed while just looking into SDFs and how to create a custom implementation of SDF is that a lot of things, a lot of transformation with SDFs are done in a way that is just doing something to the whole coordinate system, and not through, for example, adjusting this step here. So for example, we can definitely do 0.5 here, and it will create the sphere here, and we can obviously do the distance from 0.5, and it will put it in the middle. But the way it is usually done is actually translating the coordinate system itself. So for example, I can just subtract that 0.5 from here, and it will put this right in the middle. And actually now I can just substitute this with length.
Yeah,
which
that's cool.
actually I'm not quite sure if like, so we're saying that length basically doesn't imply using any square roots, or
I don't know. That's the thing. It would be interesting to know that. So because that way you can optimize. I was talking to Vit earlier. Well, man, all of you guys, you have so, from my perspective, weird names. So I never know how to pronounce that shit. But
because basically, when I was looking into it,
sorry. Vit Haratek?
Oh yeah.
Yeah, and he's quite knowledgeable about this low-level stuff. So he said to me, probably the dot product stuff is the fastest because that's implemented in GPU hardware.
Yeah, probably because when I was looking into doing stuff in script for shaders, because I actually don't usually do stuff in script for shaders because I just find nodes so much more intuitive and satisfying. Obviously, for some things you definitely need script, but for this stuff, this suffices. And what I've noticed is that you don't really have length in the reactive, the whole reactive thing in Spark. And what they have is magnitude. And if you try and add length, it actually says that it calculates the length or magnitude of a vector.
Yeah.
And so I assume that after all, it does use a square root, because if you do like magnitude of a vector, it will actually give you the whole
it's the same thing. But again, like you don't care about the exact length. But so you can just use a dot product, which gives you the squared length of the vector.
Yeah, absolutely. And so again, like, why do we care if we have a custom SDF if Spark provides us with a ready-made SDF functions?
Good point.
It actually matters a lot, because if we let's just create a SDF circle through Spark. And obviously, if I just like plug it in here, well, actually, I probably need to plug it into the step here. And I think this is because here, what happens here, I put this 0.5 into step, but I probably just better be subtracting. If we here, let's just create, is that pretty much how you set the radius?
Yeah.
And then I guess if I do this, yeah, it works. Let's just make it a bit bigger. And let's just show me for... All right, cool. Okay, so an interesting thing about Spark is that the output here is actually treated as a texture. And let's just try and make Spark give us some error. So for example, let's have a texture sampler, and let's just add some texture from somewhere. So usually I just go into like any project that I have, and I'll have some Perlin noise in there. All right, cool. And we don't really, like, I'm not planning to do anything with noise right now. It's just like a texture. And let's just use texture sampler, because just why not? So for example, let's assume that we want to displace this texture with the SDF. And so one way you can go around it is that you can texture coordinates, you plug it in here, and let's just add something to that UV of a plane to just make things distort. And again, Spark may throw out an error, may not. Let's just see how it goes. Yeah, so if I plug in an SDF circle in there, it just like gives me an error. If I swizzle X and Y, because like maybe it just gives me like a vec4 or something.
I think actually it gives you only one value, right?
It's
SDF
probably...
just, so you would have to swizzle XX, because texture coordinates has two. Yeah, no, it works.
Oh, so this works. But it's still it still won't work, because it's this is in I think this like in basically this is like a texture. It used to give you errors specifying like what the mismatch of the type is.
Right.
But for some reason, it just like says there is a mismatch in type.
But I mean, why is that the problem that it's a texture? Shouldn't it still work?
So basically, I think if you want to plug in something in here from an SDF, I think you need to sample it again. So basically, you do this. You swizzle from here and texture coordinates in here. I think it should work. No, not doing it. There's coordinates, there's sample, circle. Maybe it needs to be like a step.
No, that's weird though.
Yeah, that's really weird. And this is something that really like made me very confused when I was just starting out with Spark, because I was like, why cannot I just like add something to the UV? And I think, and again, I really hope that it will work now with this custom one. But let's just swizzle. Yeah, I think this one will give you like, let's just try X as you suggested.
Yeah, because it only gives you one. Oh, boom! Yeah. That calls for Shark Time. Woohoo!
Yeah, Shark Time.
Shark Time for YEGOR.
All right, so yeah, it works. And let me just like make this a bit bigger. And again, with SDF, it just like it won't work.
Yeah.
And yeah, all right, like you can texture sample things, and believe me, eventually it will work. I think this is just because we were indeed, though actually not, like X and Y here would be like RG of the RGB, I would assume. I don't know. But basically...
Yeah, of course, yeah, that's what it is. You could actually even put RGB in the swizzle node.
Oh yeah, exactly. So like you can go pretty crazy. There are like, you can substitute it, absolutely. But why it matters is that if you try and do some vertex displacement with that, it will actually prove to be much more difficult. So here I have a plane which is just like a very high poly subdivided plane that I just made in Blender.
Or there's also one in the asset library.
Yeah, there is one in asset library, but I just don't trust asset library, I suppose.
Yeah, it's a good point. Actually, this is a good point. Hey, so sorry, just to interrupt.
But, yeah, absolutely.
Story time. So one thing I keep noticing working with people is that debugging is like a very kind of like foundational skill that is something you really have to kind of learn, I guess. And I noticed that a lot of people, especially maybe like YEGOR said, coming from a creative background, such as myself as well, is that they tend to just crazily click around, kind of like hoping for the best. And this is something I do as well, because sometimes you're just too lazy to be like, oh, okay, so what am I doing? But it is super important to build your scenes on a strong foundation. And actually what you just said regarding the asset library is a good point. Like if you do all your assets yourself, you exactly know every point, literally in this case, but like you know exactly every aspect, and you know if something goes wrong, that this can't be the reason. So you have a strong foundation. And if you just basically bang shit together without knowing what's going on, it can fail at any point. So yes.
Oh yeah, absolutely. And I mean the whole process of like learning anything, but especially like Spark, it's like just trying beat by beat, and then it kind of accumulates over time, and then it kind of makes sense. So it's not even like a matter of like knowing specific tricks, but kind of just knowing this kind of like meta kind of how it all kind of works. I'm still struggling with like all the camera transformations, like how do you actually render something 3D on a 2D screen? Like, I mean, I can like do stuff like that.
Well, did you watch did you watch the last stream? I tried to go over it. Yeah, I think I did. Yeah, the transformation matrices stuff. This is exactly how it works. And actually, a little hint: I use that to do the billboard stuff. But even though I did prepare it for the last stream and I went through it and everything, today I was like, oh, okay, I know how it works. I'm going to do it. And then I'm like, oh, shit, it doesn't work. So I ended up actually just fucking around with stuff and kind of stumbled upon it. But yeah.
Yeah, exactly. And I was actually like wondering if you can do the same thing. So it's really good to know that it's actually possible. Like my level of knowledge of that stuff is just like, I'm not that comfortable just like going in there and combining this, which is like already like pretty complex with that.
Yeah.
But anyway, so I think before we jump into vertex displacement with this stuff, let's just displace our vertices with something which is like much more interesting. And does time allow for like us just coming up with like a custom SDF just for people to see like how it's
absolutely
done? Absolutely. Let's do that. So as you've mentioned, Inigo is like a wonderful person that's put so many great stuff out there. And you've been showing this, which is the 3D SDF functions, which he has documented on his website. And he also have this wonderful 2D SDF functions. So you have circle, you have segment, you have box, all the crazy stuff. And it goes into like pretty like interesting things. Like you don't really have like a horseshoe in Spark. So for example, if you in a trade or like do a lot of filters for like horse companies, I don't know, like maybe you want to create your own custom SDF. Who knows? Anyway, so let's just pick something and see how we can do this in patches, because obviously like this is just code, and it's actually it's doable in script. Actually, it's like much more easier in script, but let's just try and see how you actually do that in patches, just for us like to be kind of courageous enough to do this.
Absolutely. Just really quick, that one thing, and we did talk about that already, but this guy is actually he probably implemented, there's a big chance that he did actually implement the Spark SDF stuff as well, because he used to be VFX supervisor at Oculus. So basically Facebook, and he's now product manager of Quill. So he's actually working at Facebook technically. So he might actually, it's probably his code inside of Spark, maybe, I don't know.
Interesting, like you never know.
Yeah.
All right, so let's just, for some reason, I wanted to go for star, but it just like seems like a bit too much. So the hexagram actually seems like doable. Like let's just not do.
Yeah, let's do an easy one. Let's just do two circles or something.
But is it 2 circles will like just be adding stuff?
Yeah.
And let's just. It's actually like it's real quick.
All right, you do your thing. Do your thing. Oh, good. Star sounds great actually.
So let's just like copy it in here so that we just like see it nicely. And basically, this is our function. And let's see if we can do that in Spark. So first thing I usually do when I try and like create my own custom SDF based on something like that is just like you look at the inputs, and here first input is of type vec2, and it's the p, which is like position. So pretty much this will be our texture coordinates in here. And let's just like unplug it from here. Then the other one is r, which I would assume stands for radius in this case. It usually does. But like it's obviously like context related. And let's just quickly have a value in here and just like, let's call it R. Then if we go in here, we see that there is like a constant of vec4 type that is declared here. And this, like, I'm from a creative background. I won't even try and explain like what this means, but basically this is a specific numbers that applied in a certain way will give you that star shape. And you can just like look that up. Again, like I have a vague idea of how to explain that, but I will not attempt that. So let's just create a value node and like just make this a bit bigger, vec4, and I'll just quickly paste these values in here. And actually, while I'm pasting the values, I'm working on like a collection of these SDFs can translate it into Spark. So I'll probably release it very soon. But I'm just like getting some like refining stuff basically. So basically what we want to do here is this like bunch of computations. So first is just to take the position and have it as this absolute of that position. So let's just do this. And probably let's just like put it in fragment stage so that we don't run into troubles later on. And then just like quickly looking at these, there will be like a dot product of x, y of this k and of yx, and then it will also be the z and w. So let's just like swizzle all of that. So I think I'll need like 4 swizzles. So x, y, yx, and for some reason it always complains, like it just doesn't really like swizzle without any input.
Yeah, weird.
Yeah, it's really. But is Spark still in beta actually? Like
that's a good question.
I'm not really following, but I still think it's in beta. So
I mean, it doesn't really make a difference, I suppose.
Yeah. So and now let's just do quickly dot product, because we've seen that there is a dot product. So basically what's happening here, x, y, the first step basically, but they're very identical as you can see. So the xy of k gets multiplied by the dot, the minimum between the dot product of k, xy of k and p and 0.
And what's k again?
The k is these, like 4 of these, let's just call them magic numbers for the purpose of this tutorial. So basically what we'll do is the dot between xy and p, and dot product also just like complains if there is like no other inputted here, and then the dot between yx. I'll just like basically do the 2 steps right away, and then it needs to be the minimum between that and 0. So 2 means. And then basically it's multiplied by 2 and then by the same xy. So what we'll do is we'll have 4 multiplies. This one will be 2, and this one will be multiplying this minimum between dot and 0 by this. And now we basically have like these whole steps in here, and now we need to subtract this one by one from our position here. So what we'll do is we'll do subtract, and right here is position, and let's just subtract this. And now there is like you can easily make an error here and just do another subtract and subtract basically this from this, because here the p here that is used in this whole computation is kind of no longer the same p from this step. So you absolutely need to make sure that after this subtraction you go in here and you plug this in here instead of like plugging it from here. And now let's do this. So like we've covered these steps, we're very close to our amazing star or hexagram. So this one would be the, so it's a clamped value of x of the p, and it's clamped between radius by z value of k and w value of k. And yeah, I know it's like it's very confusing, And again, I'm like doing this to just show that you can do that. Because when I just looked at that, I was like, no way, I'll be able to make that in patches, but actually I can. So it's really interesting to see when it actually works. So let's just clamp the YEGOR and let's just multiply by, yeah. So here we have our R, and let's just put as 0.5. Let's have 2 multiplies. And so basically, as you can see, I'm just multiplying it by these values here, again, as specified here. I'll now clamp this value with these values. And now, all right, what happens here, it needs to be like a vec2 of like these and radius. And actually, I think on one of your streams, I've heard that like, do you have like any preference of pack versus swizzle, and like how do you pack things with swizzle?
I think it doesn't matter. It's just that how can you swizzle? You cannot do 2 inputs. Ey, Tanja und Ute, cool. Schöne Grüße zurück. Warum, wo seid ihr denn? Was Urlaub? Wie Urlaub? Ist Quarantäne. Außerdem, wieso seid ihr denn im Urlaub und guckt so einen Krempel? Sorry, I was just responding to the chat real quick.
Yeah, absolutely. So basically, as you can see, I just like quickly packed this and I subtracted it from P over here. And I really hope I didn't make any mistakes. And now it's just like a very last step of length multiplied by sine of y of b. So for length, we pretty much use that. It will be length. And now let's just swizzle. We'll get the sine. Oh, swine. Sine. Not kissing face, oh, for fuck's sake. I mean, maybe kissing face, who knows? Those are like the patches I use the most. It's kissing face all the time.
What is sine doing? It's reversing the sine or what?
So I think actually let's just try and plug it in and then see if we can just like take some parts out of it.
Yeah.
Maybe. So hopefully this will. Okay, so I think I've hidden this plane. And let's do a step.
Oh, okay. Yeah.
It's not really, and maybe we'll need to subtract. Also, so subtract, and you subtract from,
or maybe put the step to a different value.
Maybe it has something to do with the radius, actually.
Oh yeah. No, it's not doing anything. Fuck. But you know, this happens to me always the same, exactly the same. I build all this shit and then I'm like, oh my god, and then I have to go through everything again. I mean, it's exactly like you say, you can do it, but it definitely is easier to just copy and paste the code and just have it work, right?
But actually, I think for the purposes of working through patches, this actually like a really, really good approach. And let me just, I won't really like spend lots of time just looking for this. I just refresh. Step 0. All right, this should work. And I can actually just like jump into the project where it does work, which is always the way to do it if it doesn't work.
Yeah, I had the same thing earlier as well, right? Like with the sphere.
Exactly. So
I don't even know why that didn't work, to be honest, but whatever.
Yeah. So, and this one will feature some.
Anyway, you get to Shark Time.
Yeah, Shark Time. Wait a second. And yeah.
Oh, fuck yeah.
Shark Time. So basically, if that had that worked, And had we plugged that into that amazing high poly plane, we could have arrived at this, which is actually something that you cannot absolutely do with SDFs in Spark, because it will give you this texture signal. And even like, no matter how much you like sample it, like you put it from composition node, it will still like know that, hey, it's like a texture. Don't really like mess with that.
Yeah.
And so just like to go in here and show what's happening here. Again, this is the star. And again, like this is like a shit ton of nodes. So like it always like something happens and it goes in a really like weird, wrong way. But basically, all right.
So this is the same star we just built, right?
This is the, I think, no, this is not the star. I think it's probably like a pentagon.
Oh.
Yeah, regular pentagon.
All right.
So not exactly the star, but yeah, you get the gist of it. And so I've been like just working on these little like SDF substitutes. I call them VSDFs because like I primarily use it for vertex displacement. So I just like needed some letter to just differentiate.
Should have called them YSDF for YEGOR SDF.
Exactly. Like I had this idea, but it's like, yeah, maybe like, I don't know. This is not released yet. So we'll see. We'll see.
Yeah.
And actually like you can do some really interesting shit. So you can do like these exact triangles. You specify the points. And you can do like segments of a line or just like a straight line. And one thing that I'll probably like quickly touch here is like why this whole thing kind of was just rotating right now.
Yeah.
And yeah. I'm not even sure, like, have you covered like matrix transformations as in like transforming, like translating, rotating coordinate systems, or?
Yes, but do it again.
Yeah, let's just do it again. So basically, and that's actually, I think, maybe one of the reasons why Spark treats SDFs as textures, because like, again, like when I was looking at how things are done in the whole SDF world, you would rotate the SDF at the origin, then you'll translate the whole coordinate system for it to be in the middle. For example, if the 0 is, say, if the 0 is here, like if you like translate it in here and then you rotate it, it's just like it will start rotating around some weird origin. And it always like it kind of happens prior to like you actually like doing this whole shape. And with Spark, I guess like if you do SDF circle again, if you want to do SDF rotation, for example, it kind of like it happens at this stage here. And I guess it's probably like just, and again, I might be wrong, but perhaps it's just like easier to rotate stuff if it's like just a texture and then it kind of just rotates the texture. I don't know. Like it's just like my uneducated guess. But basically, if you want to go and rotate this SDF here, you use matrices for that. And like up until recently, matrices were really confusing to me. And as Christian just noted in comments just like some moments ago, like I haven't really been excited about math before I like jumped to all this creative coding and stuff. And it's been like mostly through these like playing with nodes that I kind of just like was able to visualize this stuff. And when it like finally made sense. So the way you would rotate this thing here is basically here we have our coordinate system, which basically used to generate this shape here. And all right, here I do some translation, but now I want to rotate it. And I do that by multiplying it by a matrix. And now you see it's gone. But basically, to just have it at like this 0-degree angle, you have to do it like this. So it's like 0, 1, 0, 0, 1. And it pretty much represents this kind of, so if let's just kind of go and do like coordinates system X, Y, just like have a grid in front of us. So yeah, like we have this two-dimensional system with x-axis and y-axis, and the matrix here, it actually represents the positions of this, just like a basic vector of 1. So 1 at x and 0 at y would be here, and 0 at x and 1 at y would be here. And so by messing with these values, we can actually mess with this shape here. So for example, if I do 2 here, we would see that it kind of squishes. And what it basically does is, by us putting 2 in here into the transformation matrix, it says that whatever value was at 1, make it at 2. So it basically kind of just squishes the space here. And if I do like 0.5, it just stretches it. And in order to rotate it, you will just need to do some sine cosine magic. And well, I mean, it's not really magic, but you cannot really like deal with all of this without good old sines and cosines. So let's just have our degree value here, plug it in here, and so this is our 0-degree angle, and the output of sine is 0, the output of cosine is 1, and let's just like try and do this very intuitively here. All right, let's just try and replicate this. So I'll do back. And let's try, so this 1, 0, and now it needs to be 0, 1. So if we kind of do it in this kind of naive way, it's going to be all right. But if we start putting some values in here, it will just squish. And it basically means that, well, I mean, it's not, again, something that like you invent. It's just like out there. There are specific ways of handling this. So I think this sign here needs to be the negative sign. Yeah, so now if I just plug in runtime in there, yeah, it will start rotating.
Fuck
and basically
yeah.
what it's, yeah, so basically what it does is, let's actually try and again look like trying sine cosine visualization. Yeah, so basically you can pretty much by having cosine on so like what do we like, it's gonna be like x, that one's gonna be a y. Basically it's good old trigonometry, and by going through the length of pi, you would pretty much kind of map out all the points on the circle. And that's pretty much what we're doing here. And yeah, so this is a bit of vertex displacement in here. And obviously here, much more is happening here, really. And this one is a bit kind of, I'm actually like a bit lost myself in here. But for example, here, as you can see, like it just makes a bit of float like this in here. And what I think I'm doing here is I'm probably just animating one of the step functions with like a sine of like one of the axes or something. Yeah. And so, yeah, you can do a lot of crazy shit with this, and this absolutely works with volume. So as you just shown, you can do donuts, you can do all the crazy stuff. And so let me actually, like, I'll just save this project. Unless you want to just talk a bit more about the vertex displacement.
Yeah, I mean, I don't know if you have questions, then just type them in the chat, then we can talk about that. But I would just say, just keep going, you know.
Yeah, absolutely. And so when you've shown me the stuff you've been experimenting on Friday, I was actually real surprised that we kind of aligned this way, because I was also looking at this volumetrics, because it was kind of this very cool stuff to do recently, because everyone kind of rediscovering this. And I think the first one I've seen doing that was Matt Greenhalgh.
Yeah.
All God rays effect, but then exactly this could be used with the whole approach of ray marching and actually create some cool volumes. So I'll just probably, again, because this is very kind of convoluted to just create on the go, I'll just jump into some projects that I've been messing with and try and carefully maybe try and explain what's happening in there. So one of the projects I have in here is, and I'm actually using the patch asset material, and for some reason it just will things will disappear for some reason, all these inputs and stuff. So I always need to reconnect it again. But basically local position goes in here, and then the mix node goes in here.
Oh shit! Wow.
Yeah, and what we have in here is
showtime.
It's it's supposed to go to the infinity, but it's just limited by the whole object in here. And the object is just, again, I kind of so that, yeah, I'll go for this exact same idea of yours, just have this a square voxel. But then I realized that all that matters with this approach is how many layers you have.
Yeah.
It doesn't really matter how you stretch it out. So what I did is that this is 0.5 in the Y, and it's 20 in all the other.
But hold on, so this is also just a bunch of planes stacked on top of each other,
Yeah,
right?
this is a bunch of planes stacked upon each other.
And is this a fragment shader, or is it on Vertex?
This one is fragment shader, because this will not really, I think, work on Vertex Shader, because you will not get this level of detail, especially if you scale it.
Yeah.
And
how many planes are there now in this one?
I think this is 64, so it's pretty heavy.
Yeah.
But I mean, on mobile it runs fine, and I have iPhone 7 or something.
Yeah.
So it's all right. So let's just, I'll try to see what I've done here.
Oh, the modulo is the repetition, eh?
Yeah, so the repetition is from modulo, and you basically just slightly adjust things.
Yeah, it's like a pixelization basically of the UV space, right? So that it repeats the stuff.
Yeah, exactly. So it's 0 to 1, 0 to 1, 0 to 1, and you just repeat it. But what I think could be done is that maybe there can be another texture, another coordinate system which is not repeating on top of this, and then drive some other parameter with that.
Yeah, of course.
There are all these repeating blurbs, but then some parameter of that you animate with something.
I was actually thinking along those lines as well. I just real quick, maybe I found the original post I was talking about. So this is the volume cloud I did with the exact same technique as Marius, actually. So this
I've seen that one. It's right.
Yeah,
pretty
so
cool.
this is a bunch of slices with textures exported from Houdini, and then I did what Hongwei was suggesting, just basically taking the slices and then rotating them 90 degrees. So however you look at it, it's always a cloud. If you would look at it from top, it would be a grid, right?
Yeah, exactly.
But basically what I was thinking, what would be cool is to say, because this approach is a test link for this cloud. No, I mean, this is like forever old. That's probably over 2 years old, so this would probably not work anymore. I can look into it. But basically, the problem here you have with all this Houdini stuff, or also the crazy, explosion stuff we were looking at for the Unreal demo.
Yeah.
It's like super heavy, right? It's like it needs a lot of memory. So what I was thinking, what could be cool is to combine it, to use like a texture-based volume cloud texture type stuff, but then actually do the cloud shape with procedural spheres, and that could change. So you basically could combine best of both worlds. So you use a fine texture on the as a texture, and then you use just basically make the whole the rough shape with SDFs.
Exactly, and I actually have an example just for that. So let me just quickly jump in here, and yeah, I think it's this one. Let me see, and again, this stupid patch asset material will just not keep in here. So yeah, the position will go. Let me just check if, yeah, I think it's this one. Yeah. So we'll plug this in here. And this one will go in here. And we'll have this.
Oh shit, fuck, yeah.
Which is kind of combining the two worlds and actually like having a solid sphere in here.
Oh man, that looks amazing.
And that really is kind of sort of a fire shit, which is just like a Perlin noise.
Yeah.
And the way you actually apply it like this, because it's kind of like, it's pretty much applied from each single direction. I think you, let me just quickly go in here. So you do need to texture sample the noise texture.
Yeah.
And you just like texture sample it in a way that you first do, like you texture sample it with local position.
Yeah.
So first you do
you
like
just
X,
basically
y,
you just offset the texture through the Y space of the object, right?
In this case, it's actually like, so again, let me just try and expand it and try and make sense of all of this.
You know what? This is actually really cool, because this is actually exactly what I wanted to try just before I stumbled upon this voxel stuff. This with the texture, like the one noise texture, kind of offset in a voxel, like in a volume. That's exactly what I wanted to make. And then I was like, hold on, maybe I can do the SDF stuff here. So really, really, really cool to see that.
And this is actually like the whole like movement is from an SDF, and then I subtract this like texture. And again, it's like so it's like a local position X, Y, and you get it like subtracted from the top, and then you do like X, Z, and then like subtracts it from the side, and then.
Can you maybe just show the texture without the movement? How you
let's see. So I think the movement is from here, and now it's just like the texture, and the movement is of this thing here. So I'll unplug this from here.
But the textures is also changing over the planes, right? Not every plane has the same texture.
Let me see. So yeah, absolutely. Like it's not the same texture. It's kind of just taking this noise texture and using it from different angles to kind of create this weird kind of volumetric pattern.
But is it rotated? So each slice of each plane has the same texture but a little bit rotated, or what is it?
Okay, let me just try and do this. So like if I change this like X, Y. Yeah, so here I basically have these swizzles going on here. Okay.
So it's like triplanar mapping basically.
Yeah. So this is like if it's all XY, it will texture sample just like this, and here it's like just stretches out. So I do XZ, and now it's just
Fuck,
like
man, that's so fucking amazing.
does shit from the side.
That is so fucking cool.
And yeah, and it's kind of like I didn't expect it to give this result, but I was actually quite surprised because you can do so much with noise.
You should say, this is exactly what I intended it to be. Every pixel is exactly what I intended it to be.
Exactly, like it's amazing. Really cool stuff. So let me close this one for a bit, though we'll get back to it. I actually think I also have one with noise, just like slightly differently looking one. I don't really remember if it's like way different. Oh, and these always like will appear way.
Yeah, they always appear some other place.
But hey, we're not complaining here. This amazing tool, which is really amazing actually. Okay.
No, I mean, yeah, sure, we are complaining. This is
okay, so this one, which is also like kind of
fuck yeah,
along the lines of what we just did, but there is like a bit of like this one is solid, this one is like a bit of glow, because I think we've actually like had this conversation somewhere like in Facebook in the comments while looking at this like demo scene by some guy who did ray marching.
Yeah,
and like it was like really perplexing, like how does it do all this glow and stuff, but in ray marching you do this like exactly this way, so like even glow is just like a distance from something,
right? Yeah,
and here is kind of this noisy glow. Yeah, and I think this should do it for kind of combining SDFs and textures, and now kind of being inspired by what I've seen today in the community, well, that's all those like Houdini, smoke and flames, and liquid simulations.
yeah.
I actually decided to do something like I suck at Houdini tremendously, so I went to Blender because like that's my tool of choice, and yeah, I think it's this one. So basically what I did is that I had and maybe like it will be worth it just like quickly jumping in Blender.
But can I maybe ask something for the last example, because
yeah.
So okay, so can you maybe go back to the last one, because
sure,
it
absolutely.
looks fucking amazing. I do want to ask some more things.
Which one?
The one we just saw with the glow.
Yeah,
so I understand how you make basically the frame around it, right? Like it's a sphere cut out of it, right? Like but the ball in the middle, this is basically another sphere, but it's also multiplied by the Perlin noise texture, right?
Yeah, so like it's I think it's also this kind of a triplanar application of Perlin noise, because I mean it's like you have a texture that's like there's that many things you can do with it. I guess if like you can have like a Perlin noise function, which is like a 3-dimensional Perlin noise, you can do that programmatically, but I don't know, I just decided not to go in there because I thought that maybe that won't be possible.
And but so you use because if you have the triplanar mapping, then it would be just a cube essentially, right? And you use this, and then you use another distance to make this ball.
I think here it's the same distance field, but just like different steps.
I see, yeah. And then the glow, and the glow is also again the same, but added on top of it at the end.
Yeah, and
and where do the colors come from?
Colors are just these mix nodes.
Oh fuck yeah, nice.
And I just like play with opacity and stuff. And then this can actually be like multiplied to the infinity, and you'll have this like weird labyrinth of like this glowing orbs.
Yeah.
And actually, like you actually see this in demo scenes where they actually like fly through these, but then you don't get this issue.
You see it in so higher tutorials. You watched. I can recommend it actually. He does really cool tutorials for coding in Spark. And he has an intro which looks like, which is ray marching, which looks like it.
Yeah, amazing. And so I don't know, like, did you have any questions about this one, or
I mean, this is like fucking amazing. I mean, it's so cool to see that, because again, like, this is actually what I wanted to try, and then I kind of got sidetracked by doing the torus and, you know, adjusting the voxels. So this is fucking amazing. Really great job, man. It's
thanks.
so cool.
But toruses are also like very cool. I wanted to like do the torus for this session, but yeah, I had no time. Sorry.
Yeah, donuts.
Donuts, toruses. Okay, never mind. Let's just like close this one. Let's save it, and let's like go for the final one. So basically, I just like hit pause. So what I did in Blender is that I pretty much just like added a mesh, and I won't like go into the whole process, but what you can do in Blender is that, what's that? No, solid camera. So if I go and render this, and then if I go into the compositing nodes, and I'm pretty sure like you can do that in any sort of 3D editing software, but you can actually get like a render of a Z, like a pixel of depth as a depth map, and here is just like an unfortunate distance from this guy. Let me just try and just go a bit closer. Maybe that will do. Yeah, you can see like it starts to come through. So it's basically like renders a depth map for you.
Yeah.
And what I decided to try and see like if you can actually like use this whole like volumetric approach to maybe use that same like triplanar mapping to render things from different angles and to like import your 3D model in there. And obviously if you like import it as a texture sequence, you can like do some pretty cool stuff. And I didn't really succeed at having it like from 3 cameras and perfectly just making up a really nice shape, but I kind of managed to, let me see, to do something. So where is it? Okay, so here's our guy, and it comes from this texture here.
Yeah.
So basically, this is like my first attempt at trying to use a texture to visualize some volume, but not really like add any SDFs into the mix. And what it does is you pretty much like sample it along, again, say X and Y, and it will have like this texture on each and single plane.
Yeah.
But then the step of like you put it through the step, and the whole factor in the step would be the like the Z of the cube, and it will like nicely go through like all the gradations and stuff. And I think I also had it like rotating. Yeah, it's actually rotating with the same like matrix transformation approach. And obviously, like you can go much deeper in that. I think Inigo here has lots of really cool stuff. So, for example, for twisting, for bending, and it's all like it's super simple if you just like try and do it like step by step. It's actually like not that hard at all. You can do really cool stuff with like combining them with like a smooth union, so it's like just like blends in nicely. You can just do some like revolutions of like some shapes and create some other shapes just like from 2D shapes. You can do like this kind of walls of like a phenomenon. And this one's
for
actually
that one,
really
actually,
easy.
for that one, I was curious because for that function, you need to give the function the SDF itself. How you would do that? I don't know. I just scrolled past it.
Actually, let me just discard these, and I'll go in here, and I'll just like try and show it on the 2D version because I couldn't. Again, I kind of like scrolled past it in the 3D version. All right, which one is so many things in here? Yeah, let's make this one disappear. Okay, I had this. The rectangle has this material has this output. And let's just go in here. Yeah, so let's actually try and use one of these little patch assets that I've created. So, and actually I will not go for vertex attributes. Let's just go for function because I think it should work. Really.
Should work, yeah. I'm curious about that because if you do function and you do 2 values, or how they call it, it gives you the UVs. But what are the other things? Like vector 3, does it give you the point position or what?
Ooh, that's a good question. I've noticed that function doesn't really work with local position. It's kind of the same thing. It just like throws an error.
Oh, yeah.
But who knows? Like theoretically, I guess it should actually give you the the third axis. So let's just try mix and just do a couple of colors. Yeah, have this nice triangle in here, and this one, like you can actually just.
Nice. Hey, did you guys see the thing on the forum where someone remade the N64 vector game Star Fox?
Oh, that was amazing.
That was crazy, man.
Exactly. I was like, this is like, it's like this, but way more like, I'm not even sure, like, because I think even like it still has like that pixelation, but it kind of matches. It's just, it's crazy.
Yeah. Totally
so
crazy.
Yeah, so for something like we've just seen, I think I haven't really saved it, but I have it somewhere around here. Ooh. Oh yeah, annular. So this is pretty much the same thing, but just for 2D. Yeah. So now if I do this, it will basically.
But what happens inside of the VSDF annular?
Yeah, exactly. What happens inside is super. It's like it's that simple. We'll actually.
It's empty.
It's so simple that it's really hard to just like find it because it's just like somewhere. Yeah. So what it does is you put it through absolute and you subtract. And what I think happens is that basically the SDF is like if we don't put it through this, like this is right here, like this is 1, this is 0. If it's like absolute, it should actually be like, I think it should be all just like one color. Yeah. So now it's all like the shape is in there, but we kind of removed that sign part of it because it's all like positive. And now if you just like subtract from it, it kind of will kind of move out those edges.
I don't know. I kind of have to wrap my head around that again, but it works, so that's great. And I mean, I guess we should try whether it works in 3 dimensions as well, maybe.
Exactly. Do you want to do it now?
I don't know. I mean, it looks kind of quick, right? Like why not? If you want to.
And actually, just like to quickly mention what happens here, I've removed the absolute and I still have subtract. And what it's useful for is kind of rounding the edges. because like the SDF is like at 0, it's like very like it's like it's all sharp edges. But then
so
as
this
it,
is
like,
actually a
goes
great picture. So what you're doing with subtracting, you're basically moving the edge further up in this direction. So that's why it's rounded.
Yeah, exactly. And if I'll add, so in this case with this, it will be like going inside, and obviously like it will not be rounded.
Yeah.
Okay, so let's discard this. And which one? Let's try this.
This is that looks so fucking amazing. I think this is my favorite. This looks so cool. Yeah.
I mean, fire always looks really good. Like I've tried different colors, and I was like, I don't really want to go like for fire, but nah, fire looks good. Okay.
But also, can I ask something else about the scene? So you are doing this triplanar thing you showed with the monkey head?
Yeah.
But then you are also somehow animating that noise. How does that work?
The way noise is animated is just like literally me shifting that texture. So it's just like it kind of happens so that it like looks very organic and stuff.
It looks so fucking cool, man.
Because like when I was saying that like I didn't expect it to look like that, I was thinking like, all right, if I just like apply it from different angles and like move it, it is the same texture moving. Like I thought that it will not look as good, but it actually does.
It does. It looks amazing.
So actually like probably would make more sense to just like not use that one and
just use the simple one.
So right, local position, swizzle, and actually like fragment stage, swizzle X, Y, and Z, and then the length, and then we'll subtract, which is like moving the edge, as we've just learned, and now it will be a step. And then it will be a mix node. And hopefully it will work. So let's just do it like this. And it works, but this one is, So, all right.
Nice.
I think in order to see that whole like onion thing, we kind of need to just like cut it by half.
Yeah.
And let's just, I think it like just will probably come down to just like clamping some value or something.
Yeah, just clamp Y at 0.5 or something like that.
So let's just do maybe like swizzle 0y0 and like.
Can you put? I think maybe you can just put clamp to vector 3 and then just put it in there.
I think it might like clamp it to.
But the local positions, the values are actually crazy small, so it might be 0.
Yeah. Exactly. That's like very good point.
0.01.
Or maybe
because it's in meters. Oh, this kind of works. It does something.
Kind of does something, yeah, but. See, we kind of. Oh, look, we've clamped. I've clamped it here. Actually, what helps me a lot to debug these is to just kind of reducing opacity a bit.
Oh yeah.
And then you can kind of, if something is happening in there, like you will know.
Yeah, and it looks much cooler that way also.
Oh yeah. So fuck's sake. Let's try and clamp this one. So 0.5, and it's like it's not necessarily even like right X 0 Z. Add it, and again, no idea if this will work.
Oh, nice! We made a new shape.
We made a new shape, exactly. This calls for a Shark Time. I hope that's
totally.
Oh,
and UFOs also.
To maybe like, I think we'll probably be able to like see it somewhere here.
Yeah.
maybe like, all right, let's try this, and then oh no, not Z. X 00 Z X by 0. Yeah, so that like we kind of look at from the top. And so let me just like reference that function real quick. Okay, so
the chat is saying that that's a phallic SDF function.
That's it's an inverse phallic. It's like it just isn't really like
it's hanging down.
Just hanging down. Just
it's not exciting yet.
No use. But when it's like hollow and like in onion shape, it's just like it will work. Trust me. All right, so we'll do like an absolute this, and hopefully this will work. Though I think I've tried this and it didn't. But okay, I don't know.
Oh, it does something.
Yeah, see, I think it actually...
Oh, it does work. Fuck, yeah.
It does work. Absolutely. So... Again, a bit hard to see, but oh, yeah.
Oh, man. Oh, this is... Oh, man.
No, it's actually pretty cool. And
so it works. It just works. Amazing.
It definitely works.
That is fucking amazing. Man, this is so cool.
And then you can kind of just like repeat it, and it will be like this weird onion shape. Because, you know, this, oh no, and I broke it. Never mind. Yeah, volumes. Exciting
Fuck
stuff.
Yeah. Fuck yeah, volumes. I would say that. Yeah, man, this is actually, wow, this is has gotten to be super exciting stuff you've shown. I hadn't even anticipated all that goodness. So thanks so much for that. That is fucking amazing.
Yeah, no worries. I mean, I have been like spending my days recently exactly like discovering this, and it's like so amazing that we kind of aligned on this topic because it's real good.
I mean, it would be interesting to look into how that is actually useful. I mean, your fire thing is so cool. That looks so amazing. That's so cool. That is obviously, you could totally do a fucking amazing fire with that. You probably should.
I would like have one, but it's it definitely calls for like a 3D volumetric fire.
Amazing. And yeah, I mean, you know, it does work on mobiles. But I mean, considering latest smartphones are actually faster than computers. I mean, my iPhone is significantly faster than my Mac I'm using to.
Oh yeah, like for graphics, it's like way more optimized, I think.
Yeah. Yeah. Very cool.
Right, so let's just save this, and I think let me like quickly open these. I'm not sure what's happening here. No, that's the same guy.
Oh, that's really cool too.
Discard. It will be cool like when it's actually like properly triplanar representation of a 3D scene. And,
so
like,
I mean, there are some there are obviously some conceptual let's say restrictions to that approach, because obviously what you're doing now, if I understand correctly, is you have a cube and you cut it from one side, right, up to a certain point.
Yeah.
And there's in ZBrush, there's this what's this thing called again? There's something to use to modeling room. I don't know. Hold on. Let me just cut room or something it's called. I'm not a big ZBrush guy, but
haven't worked in it in ages.
Snapshot 3D, that's I think what it's called. Yeah, so I'm just gonna, you know, do a quick run through to the tutorial. So basically what this function is in ZBrush is you can take an image and then basically, I hope that this is actually the function I was talking about, project it onto 3D stuff and basically cut shit out. Maybe it's not that one. I don't know. See, yeah, see, this is kind of like cutting it. So this is basically similar to
yeah, that's how you can actually create shapes with SDFs, because like you can either combine them like from different angles and just like do some Boolean operations, or it could be like just revolving around some axis. But yeah, this is like one of the ways. But I'm actually like also curious as to like how applicable this is, because I'm definitely like not seeing myself doing like client work with any of that anytime soon.
Yeah, me neither. But you never know. And also, again, like the fun with it, I think, is to learn that stuff. And it definitely opened my mind quite a bit doing all this math thing. But yeah. Hey, Lasse. Yeah, we actually just kind of wrapping up. Or I don't know. Do you have any other things to show? I mean, you showed. I mean, it blew my mind today what you showed. So cool.
Not really. Like I was doing some like the kind of a volumetric thing when you kind of get camera feed, and then like there was like a grid of SDFs, and it's also like animated with noise, but it's like it's probably like for later. So I guess that's it for today. That's from my end.
Cool. So let's see. Chat, guys, if you want to ask something, do it now. And I'm gonna look into whether we find some nice channel we can raid. Or maybe you can also just recommend a channel if you want.
Actually, no idea. I'm actually, I've never made it to like this very end of your Spark Sunday, so I have no idea what's happening right now.
Oh yeah, okay. So how it works on Twitch is that you can raid another channel. That means that we're gonna all basically jump to another channel, and you know. But the problem is I just have to find. We already because I'm new to Twitch also. Is that I don't have that many things yet.
No, like same for me. Kind of it forced me to like pick some interest. So like I picked NASA because like it was like trending or something, but then I had to pick like GTA 5 or something. And
exactly. But it's mostly gaming, right?
Yeah.
So it's not necessarily always that you find something. Maybe I can look for 3D.
I mean, I think like that, like your post on Facebook about that guy who wrote this like amazing demo scene.
Oh yeah, Evil. Yeah, he is. But he's not streaming right now.
Ah,
yeah. But
it needs to be like
this is
live.
Guy, yeah. He is sometimes he's live, but not now, unfortunately. But like this is. Oh look, there's some suggestions, but it's all offline. Oh, we could maybe search for demo scene TV live demo streamer. Oh yeah, hey, that's actually great. So this is probably not this is probably just demos, but it's just one person watching. Anyway, let's rate this channel because Homer was saying he should watch more demos. Oh, actually, before we leave here, this is the shout out to Sohail, who's doing scripting tutorials, and his intro on YouTube. See, is this ray marching thing, which looks exactly like what you did, basically.
Yeah.
That's
actually like a very like typical trick in ray marching, where you want to like just like not do a lot of computations, like
Okay, well no, this is kind of lame. I don't know. Let's see if we can find something else. Yeah, guys, let me know what you wanna do. And if not, I'm just gonna, I don't know. We have recommended channels here. What's this? Science and technology. What's he talking about? Oh, he's doing some coding. I don't know. Let's see. Yeah, I don't know. That looks kind of What's he doing? That's maybe music. Like I got into Twitch because of music production.
Ah.
Yeah, and so I have a lot of music. What's he doing? Yeah, he's always he's always ghetto. He's German though. Oh, I mean, I don't know. He lives in Germany, I suppose. Recommended. What's this guy doing? Playing games. Music. Oh, actually, we can also browse and say art, making art or something. Hold on. Live channels. Yeah, drinks definitely when pubs reopen. Oh, this looks nerdy. What's he doing? Oh, he's building keyboards. This is what we're gonna watch, guys. Yeah, I also have this little here streamer keyboard, which I always use to do the Shark Tank stuff. Alrighty, so yeah, thanks everyone for tuning in once again for your favorite show on the internet, which is the what did I call it today? Superconducting Subterranean Saga.
Absolutely.
Yeah. And thanks for having us. I hope you learned something. I hope you had fun. I did have a fucking amazing time. Thanks so much to YEGOR. It was so cool.
Oh, thanks to you, Mara.
And I have to kind of like rewatch that stuff myself and try the texture stuff. So now we're gonna rate the guy putting together his keyboard, which is just about as nerdy as what we just did. So guys, have a good night. Take care. See you around. Bye bye. So this is 10-second countdown. And now I'm gonna click right now. All right. Bye-bye.